Now we're getting into the perfect squares. And so there's two different ones. They're really the same thing. We have a squared plus 2ab plus b squared equals a plus b. Seems complicated, but honestly, just realize it's the same factor twice. And this one's the same factor twice again, just with a minus sign, and this ends up being negative. So really not too big of a deal there. But just like we saw in the last section, if you recognize this pattern, it's going to help you get to this. And not so much for these. These are going to be really easy. We can factor those no problem. But maybe when we get to questions like this, recognizing that pattern is going to make things a little bit easier. So the traditional way that you would go through these is you could just figure out, hey, what multiplies a 9 and adds a 6? Well, 3 and 3. So we could just say we have x plus 3 squared and call it done. Or let me not just put the squared yet. X plus 3 times x plus 3. And that equals x plus 3 squared. It's your choice on how you want to leave that. It should accept either answer. This is a little easier to write, and it's good to recognize that this is the same. So what's the pattern method? Well, that's whenever you see right here, we have a squared and then b squared. Look at the two extremities, the left side and the right side, and see that they're both something being squared. And then if you figure out whatever those values are inside there, the middle value needs to be 2 times AB. Now I realize that's always going to be an even number there. So let's see if we could try that on this one. Something simple. Like I said, as these get more difficult, you're going to want to recognize those patterns. So can I write this as something squared, and can I write this as something squared? And the answer is yes. This could be x squared, and this could be 3 squared. So the next question is this 2 times the product of these. So 2 times x times 3, yes, is 6x, right? That could be rewritten as 2 times 3 times x. So we're good. Because if let me just write what we have up there. It's a squared plus 2ab plus b squared. This is the form, this is the pattern. So if these can be written as something squared, and that middle term is 2 times the product of those two things, then we're good. So then the answer would be a plus b squared. Or if this was a minus sign, that would be a minus sign. Just notice that the sign there will match up. So anyways, that's not done. From there, now we know what a and b are, so we got to write the answer, the factored form. So a is x and b is 3. So it's not the easiest thing in the world, but it's not really that bad either. So let's go ahead and look at this one, but more in that pattern method that I was showing you earlier. So obviously you could do the diamond method on these simple ones, and if you feel more comfortable doing that, go ahead. If you want to wait for the more difficult ones for the other method, that's fine. So we want to look at the left and the right and see if we could write these as something squared. So the answer is yes. This could be written as x squared. This could be written as 7 squared. Now just to double check the middle, it's 2 times 7 times x. Does that check off? Yes, 2 times 7 is 14. So we're good. So realize this is a, this is b. So we'll have a plus b squared, and that's the factored form. Oops. All right, so looking at these, it kind of rearranges things. Now remember I told you, look at this sign right here. That's the sign it's going to take. So it's going to be a minus b squared. So let's figure out what a and b are. So let's see if we can write this something squared. So 7 squared and x squared. So that's good. Is the middle, could be written as the product of those two. Yes, so we're good there. So a is 7, b is x. So 7 minus x squared. Remember, it's a minus because what I highlighted there. Then last, this one, you can see this could be written as 9 squared and x squared. So 9 plus x squared. Just kind of jump to the end there. So like I said, if you want to use this diamond method, that's fine. But sometimes when we rearrange them or we get to the more difficult cases, like we'll see in the next section, that makes it kind of difficult.